Hey Finxter, what's up? It's Chris, founder of Finxter.com, and in today's video I will show you the Python less than or equal to operator. So this is part of my Python basic operator series. Actually, initially I focus on the comparison operators, and we will just go over all operators in a brute force approach, even if you think you know all of them by heart. But I think by watching through this video you will definitely learn something new today. So let's get started. For example, we will look at the Python magic method, and which is like the dunder method. I call them dunder methods, or they are usually called dunder methods or magic methods. How you can implement your less than or equal to operator on your custom Python object. So this is like advanced Python stuff. So let's dive right into a very basic example. So the Python less than or equal operator, it basically returns true when its left operand, like this one, the left operand could be a number, or could be even a string or a list even. It returns true if the left operand does not exceed the right operand semantically, right? So it is either smaller than the right operand, or it is equal to the right operand. So for example, in this case, this here would return what? True, yeah, because 2 is smaller than or equal to 3. This one would return true as well, right? And because 2 is equal to 2, so therefore 2 smaller than or equal to 2 is actually also true. But then also we have we can do something like this. A is smaller than or equal B. We can even have strings with more characters. We can have lists, for example, as well. So we can compare lists like 1, 2, 3 is smaller or equal to, say, 1, 2, 3, which should then be true, right? Because they are equal. Let's have another list example. So this list 1, 2, 3 is smaller than or equal to, say, this list. What do you think? Yeah, this last comparison here would yield false, while all other ones are true, right? And why is that? Because in this case we have we have a list with 3 elements, 1, 2, 3, and it basically compares element-wise the list. So for example, it compares the first element of the first list with the first element of the second list, and only if they are the same, it actually proceeds with comparing the second elements of the list, and only if they are the same, it competes comparing the third elements, and so on. And if the list has different length, then it just assumes for the smaller list that it is filled with like the minimum values. Okay, so therefore, I mean, say for example, in this case, it would still be false because this list here is considered to be greater than this list because it has an additional element, a third element, which this one doesn't have. So, but if you have the example previously here, then this is even more clear that even if this one would be like 999, so a very large number, it doesn't compare the sum of the list or anything. It just goes from left to right, and you see like this one is already larger than this one, so therefore it yields false. Okay, so let's run all of those in the Python shell, and here you see the execution state. So we have a lot of trues, and then we have one false operator here for this list. Okay, so far so good. So we can use it for lists, we can use it for strings, we can even use it for tuples. Maybe let's have a very quick example. So we have 1, 2, and check whether this is smaller or equal to 1, 2, 3. So let's, based on everything you have already heard in this video, you should be able to figure this one out. So what do you think? You can also pause the video. What is the result here? Yeah, it's true. Yeah, why is that? Because this one, basically the first 2 elements are the same, so it uses a third element as a tiebreaker, but the first one doesn't have a third element, so therefore it assumes like negative infinity kind of as a first element, and this, which is smaller than this one. So the result of the smaller than or equal to operator is true as well. Okay, you can apply to lists, strings, tuples, all types of iterables or sequences. You can even apply to float values, but then you need to be pretty careful. So for example, if you have 1, 2 is smaller or equal to 1.3, so this should be true. Yeah, so you see it here, last output of this is true. So this is a case, but it is a bit dangerous if you apply it to float values. Why is that? So let's have another example. Say we calculate 1.92 minus 1.52, and now we check if 0.40 is smaller than or equal to x, then we print yes, otherwise we print no. Okay, so what do you think is the output of this code? You can also pause the video. So here you calculate 1.92 minus 1.52, which should result in 0.4, right? So you would expect x to be 0.4. So if you now use this comparison, 0.4 is smaller than or equal to 0.4, then it should, I mean, intuitively, so mathematically at least, it should return true, right? So we expect yes to be the output here. But in reality, if we run the code, we see the result is no. Why is that? So it enters the else branch, even though the result of this computation here is should be 0.4. So let's print x. Here you see x is, the value of x is 0.3999999. And this is because the float representation is not perfect. It's not, if you, so Python or any programming language actually in floating point representation is able to encode an infinite number of numerical elements, right? So you can, you actually may want to try to encode any number, any numeric value in a fixed number of bits, which cannot be possible, right? Because you have a fixed number of bits. So this means that you have a fixed number of different combinations of bits, no matter which encoding you are using. You have a fixed number of different of different bits. So for example, if you have like this combination of bits, this can represent one number. It can only represent one number. So now if you flip one bit, this first one say, all the other bits remain the same, right? So now you have flipped only one bit. Now this can encode another number. Okay, so it doesn't really matter how we actually encode the number. You can see, like, this is plain and clear. Yeah, you can, for n bits, you can encode 2 to the power of n different numbers. And floating point is no exception. Floating point is just a very smart way to encode numbers. But of course, you cannot encode all numbers with a finite number of bits. So therefore, all floating point representations have a small error. Okay, so it's like, think of it as a like delta or step size delta. So you can only encode a certain step size between two small decimal points, right? So for example, it may not be able to capture the difference between this number and this number, okay, and or maybe even 2. Like it may not be actually able to capture this difference, which means that it maps both numbers to the same bit representation. So you can never be sure when this happens with floating point arithmetic. So therefore, floating point arithmetic in computing, it must be used very carefully, and you should never actually compare those numbers, because you have seen the small difference. If you use equality, for example, of 0.4 is equal to 1.9 minus 1.52, then this should actually return false, right? Because they are not really the same. They are mathematically the same, but they are not in the code. They are not encoded as the same number. So therefore, like, this is quite dangerous. And each time you have the equality operator on floating point numbers, you should be very careful. And smaller than or equal to operator is actually, it's an equality operator, so therefore you run into this problem. Okay, how can you fix it? Yeah, pretty simple. So I will just give you the code. You can import the decimal data type actually, and you can create decimal numbers like this. So you pass the floating point number as a string into the decimal constructor, then you create the same numbers as before, right? So let's go back. These are the numbers 1.92, 1.52, and And here we again have 1.92, 1.52, and we calculate minus, so the minus operator on actually those decimal representations. And only if these decimal, and then again we have like the decimal representation of 0.4. Now we can check whether it is smaller than or equal to x, and now it should actually be able to figure it out. Okay, so the result should be yes. Okay, so now you see the result is yes, so therefore it works like this. So you can use decimal data type, which is more precise for this kind of problem. Okay, so I think this was quite important for the less than or equal to operator. So you can also chain it, obviously. So you can do the following, like for example, say you take an input from a user, asking them for their age, and then you can check if, say, your age is between 5 and 18. Print your print hello world, else print good evening. Something like this, okay? So you can use actually chain together the smaller than or equal to operator, and this is basically semantically identical to 5 smaller than or equal to x and x smaller than or equal to 18, right? So this is basically the same. You could just replace it and obtain the same result. So if you run this code, it asks me about my age. So say my age is 99. It just prints good evening, right? And because we entered the else branch. Okay, so so I think these were the most important things I wanted to show you, and maybe we can also have one more discussion about using it in a for loop. So there's no less than or equal to condition to be used in a for loop, but if you want to iterate over all elements in a given iterable that are less than or equal to an element y, we can create actually a filtered list with list comprehension. So let's have an example. Say you have elements 1, 3, 5, 7, 9. So these are some elements. We have a value 5. And now we want to actually iterate over all elements in a given list such that the elements are smaller than or equal to our value y. How can we do this? We can use list comprehension. And list comprehension starts with the square bracket notation. Then we have the expression and the context. What is our expression here? Yeah, we simply use the identity expression x, and then we iterate over all x in elements. So in our original list, we iterate over all elements in our original list, but only if the element is smaller than or equal to y. Okay? And now we can print the element, for example. Now you can pause the video and try to figure out what is the output of this code snippet. There's a small exercise. It would be 1, 3, 5. Okay, so because 1, 3, 5, those elements are smaller than or equal to our value 5. Okay, so I think now you have learned everything you need to know about the. No, you don't. You don't. There's one more thing, which is the magic method. We can use, for example, a class person. So this is our custom class. It has constructor self age, and we set one attribute in our class. Again, we create a person Alice. Alice is, say, 18 years old. We create another person Bob. Bob is 21 years old, and then we create another person Carl. Carl is, say, 24 years old. And now we can do the following. So for example, we can have Alice is smaller than or equal to Bob. This is what we want to do, but can we already do it? No. If you run the code, it gives me a type error that smaller than or equal to is not supported between instances of person and person. So because our class person doesn't actually define what does it mean smaller than or equal to between two person objects. So we can, if you want to fix this and also allow comparisons on our custom object, we can define the lower than or equal, short LE, method, and it takes two arguments, a reference to the instance itself on which you want to compare it, and a reference to another object with which you want to compare this object on which it is called. And then we simply return a Boolean value. So Boolean value can be, for example, can come from a comparison of our attributes. So we compare our age attribute, our own age attribute from this class person, from this instance person on which you call it, and you compare it against the attribute from the other class. And now we have reduced the problem of comparing two persons to the problem of comparing the age of two persons, which is already well defined. Yeah, so we can like the age will be an integer number, as you see here, so therefore we can easily perform the comparison. So if you run this code, we get true. If we compare Bob against Bob is smaller than or equal to Alice, for example, we get false. So let's make Carl also 21. So now we compare Bob is smaller than or equal to Carl. What do you think is the result? So the result is true, yes. Because why is that? Because so they are the same. They are considered to be the same because Bob and Carl have the same age. So therefore they are equal. So we can even could even ask whether they are equal and would. Okay, so this is okay. So no. This is so if we should also define the equal self other return self age equal other age. So now if you run it, it actually returns true, right? Okay. So yeah, I think that's enough for today. Thanks for watching this video and see you in the next video. Bye.